There are places on Earth so quiet, you can almost hear the sand drifting with the wind. There are creatures that spend their entire lives hidden in darkness, and humans have only just discovered them. And there are mysteries that, the deeper you explore, the more beautifully strange this world becomes. Welcome to Relax Story, a place where we do not rush, where things are not loud. We simply slow down for a little while together to explore nature, hidden mysteries, and sometimes a few facts that make you quietly say, "Wait, seriously." Now then, get comfortable. Our journey is about to begin. 5:12 a.m. The eastern waters above the Tonga Trench still rested beneath a deep blue layer, nearly 40 minutes before sunrise. The support vessel maintained a steady heading across open water, roughly 340 kilometers southeast of Tonga Tapu, where the seafloor beneath the hull shifted from around 180 to more than 260 meters deep, just above the transitional zone leading gradually down the trench slope. 2 days earlier, a minor low-pressure system had crossed the South Pacific, but by now, the ocean surface had almost fully stabilized again. Long swells continued rolling outward in wide, even bands with no unusual turbulence forming around the vessel. Ocean currents still moved steadily southwest, gentle enough that the reflected surface patterns remained smooth instead of tearing apart into fragmented patches of interference. The horizon had not yet caught direct sunlight. Inside that pale blue darkness, the sound of water brushing along the steel beneath the hull carried more clearly than the low engine throttle itself. Behind the support vessel, the towed hydrophone array had already been fully deployed before dawn. The first layers of biological noise began appearing across the acoustic monitoring displays inside the technical bay as continuous fields of shifting signal density. The ocean at that hour still felt expansive, stable, alive beneath the surface, even though almost nothing could be seen beyond the long dark swells stretching toward the trench corridor farther south. The expedition crew completed final checks on the passive listening systems, while the CTD rosette remained secured near the aft deck. This mission was not prioritizing active scanning. No high-intensity sonar pings were being sent into deep water. The survey began with listening. The initial objective focused entirely on biological acoustics, migration soundscapes, and the structure of the scattering layer above the trench slope, where millions of midwater organisms typically formed dense biological reflections during their daily light-driven migrations. As the vessel continued slowly along the trench edge, the first flying fish began appearing near the bow. They burst from the surface in small groups of 6 to 12, skimming just above the displacement waves created by the hull, before gliding several seconds through the dim pre-dawn air and vanishing back beneath the dark water. Their enlarged pectoral fins spread outward like thin reflective blades, catching the faint blue light overhead. The behavior usually appeared when flying fish reacted to predators below or to large disturbances moving through the surface layer. In the tropical open waters surrounding Tonga, their presence was considered part of the normal surface ecosystem rhythm. Nothing suggested the upper food chain had fallen out of sync. Small movements around the bow still followed familiar open ocean biology. The sea at that moment felt stable, a living environment still full of sound, full of reaction, with no visible absence yet forming inside the ecosystem flow. While the flying fish continued crossing through the waves ahead of the support vessel, the hydrophones trailing behind began registering denser sound layers rising from beneath the thermocline along the trench edge. Lo, even clusters of clicking signals appeared first. Then the field widened into a continuous band of acoustic activity deeper below. Only minutes later, a pod of short-finned pilot whales surfaced off the port side. Roughly 14 individuals moved parallel to the support vessel for nearly 9 minutes. They never fully breached. Smooth black backs curved briefly above the waterline before disappearing again beneath the surface. Pilot whales belonged to the Odontocete group, highly dependent on echolocation for navigation and prey tracking in deep ocean environments where sunlight no longer held biological value. The hydrophone array captured their click patterns with remarkable clarity, evenly spaced intervals pulsing steadily beneath the water column. On passive sonar, the turbulence surrounding the pod appeared as soft, drifting distortions stretching across the scattering layer before slowly dissolving into the darker water beyond. The acoustic crew considered it an ideal baseline for the trench edge soundscape. The ocean still sounded tense, continuous, biologically active. From distant whale clicks to the deeper crackling noise of snapping shrimp below. The entire acoustic field carried the sensation of a massive underwater respiration system maintaining itself beneath the dark Pacific surface. The nearly 180-meter towed hydrophone array continued absorbing layer after layer of biological turbulence. Snapping shrimp noise formed endless chains of fine crackling static throughout the tropical soundscape, generated by cavitation bubbles collapsing when their claws snapped shut at extreme speed. Beneath that constant noise floor, distant whale clicks continued echoing through the water while the scattering layer shifted slowly with the currents below the thermocline. Then, one of the acoustic technicians noticed something small far east of the trench. Biological noise density there measured roughly 11% lower than expected. The reduction was not large enough to trigger concern. The ocean soundscape still remained full of life, but the low noise region did not appear random. It extended nearly 40 kilometers as a narrow corridor running parallel to the trench edge, as though something beneath the surface had begun thinning the biological response layer below. The support vessel maintained its original course. No one aboard treated the deviation as dangerous, until the hydrophone array detected a brief vibration beneath the trench edge. The signal lasted less than 2 seconds. It did not resemble a whale call. It carried none of the structure associated with tectonic cracking along the seafloor, nor did it match cavitation noise from the vessel itself. The sound arrived as an extremely fast compression pulse, then vanished completely from the soundscape. Immediately afterward, the pilot whale pod changed direction. There was no panic burst, no violent acceleration. The whales simply drifted gradually away from the trench corridor while maintaining formation, disappearing slowly into darker southern water. The hydrophone feed soon returned to normal. Whale clicks faded with distance. Snapping shrimp crackle once again filled the acoustic background. But inside the acoustic bay, the technician quietly marked the timestamp of the brief vibration, because it was the first behavioral deviation recorded before the expedition had even truly descended into the Tonga Trench. As the support vessel continued deeper into the trench corridor, the scattering layer became more defined across passive sonar. Yet beneath the biological reflections, several elongated dark gaps had already begun forming between the continuous turbulence fields, as though the ocean soundscape below was no longer entirely connected. 7:40 a.m. The sun had fully risen above the Tonga Trench. At the surface, the ocean still held the bright blue stability typical of tropical offshore water. Small wave patterns reflected sunlight in long, smooth bands, revealing almost nothing unusual beneath. But between depths of 320 and more than 500 meters, sunlight was already being rapidly consumed by the dense water column. Pale blue tones disappeared first. Then the last remaining traces of scattered light faded around the upper mesopelagic zone. By then, the expedition had already moved beyond the layer where direct human observation remained useful. Passive sonar became the primary tool for reading the biological structure beneath the trench slope. The pilot whale pod from earlier had continued away from the survey region. For more than 30 minutes after the first short vibration, the hydrophone array still maintained what appeared to be a mostly normal background soundscape. Shrimp crackle remained buried within the distance. Small turbulence signatures still drifted along sections of the scattering layer. The crew did not yet consider any of it dangerous. All incoming data continued being processed as standard environmental observation, focused on biological density, migration positioning, and minor acoustic field fluctuations along the trench boundary. Then the sonar mapping began to change. The deep scattering layer ahead no longer appeared as one continuous biological mass. Across the display feed, the biomass layer that normally formed a dense, uninterrupted band had fractured into separated segments. Between them, elongated dark corridors stretched downward along the trench direction. They were not completely empty. They simply lacked biological reflection. Under normal conditions, the scattering layer represented millions of mesopelagic organisms participating in DL vertical migration, one of the largest synchronized biological movements on Earth. During daylight hours, small organisms descended deeper to avoid visual predators. At night, they returned toward shallow water to feed on zooplankton. The movement was so immense that sonar systems had occasionally mistaken scattering layers for false seafloors. But over the Tonga Trench that morning, the biological reflection layer had not vanished. It had fragmented, as though the biomass itself was avoiding specific sections of water. The crew initially recalibrated the sonar array, searching for technical error. None appeared. Optical conditions within the water column also showed no significant enough difference to explain such long continuous gaps. That left a different possibility slowly forming across the monitoring stations. Were the organisms avoiding light, avoiding predators, or avoiding the water beneath the trench slope itself? To investigate further, the expedition shifted focus toward the organisms responsible for most of the scattering layer reflections. Lanternfish soon began appearing more clearly across the tracking feed. Small bodies lined with weak, glowing photophores drifted in dense formations through the dark water column. Normally, they formed one of the most stable components of the mesopelagic ecosystem, maintaining migration rhythms tightly synchronized with the light cycle above the surface. But inside the survey region, several lanternfish clusters abruptly stopped descending. Surface sunlight was still increasing with the progression of morning. Yet the schools no longer continued deeper according to their normal pattern. Instead, they turned laterally along the trench edge. What made the behavior stranger was the absence of any escape burst. The formations maintained unusually stable cohesion. No panic spread through the schools. No large predator appeared on sonar. Water turbulence did not increase. The fundamental survival rhythm of the deep layer simply seemed interrupted by something still hidden below. The moment the migration layer altered direction, the hydrophone array also began losing a sound that almost always existed in tropical waters: shrimp crackle. At first, the change was difficult to detect. The acoustic field did not become silent. It merely felt as though the vessel was passing through different pockets of water. For short intervals, the crackling noise diminished sharply. Then it returned. Minutes later, it faded again near another section closer to the trench axis. The biological pulses that normally formed the constant background texture of tropical ocean sound now appeared in broken fragments. What stood out most was that the pattern did not follow natural depth gradients, nor did it align with any clear oxygen or thermal variation. The ocean was not becoming silent. Certain sections of water were simply quieter than they should have been. Had the shrimp static alone fluctuated, the expedition might have dismissed it as localized habitat variation. But buoy tracking data simultaneously revealed a much larger pattern: a sperm whale migration route that had crossed the trench region for weeks had shifted nearly 18 kilometers north. Not a single individual. The entire route had moved away from the survey corridor. These deep diving predators, heavily dependent on echolocation clicks while hunting squid through abyssal water, were now avoiding the same region where the scattering layer had begun fragmenting. No predator appeared, no chase pattern emerged, no burst movement spread through the biomass, only avoidance. The crew continued comparing whale route deviations against the dark sonar corridors when the hydrophone system suddenly recorded something entirely different from every previous fluctuation. For exactly 14 seconds, all biological acoustics disappeared. No whale clicks, no shrimp crackle, no fish layer turbulence, no movement noise within the scattering field. The hydrophones themselves continued functioning perfectly. Mechanical signals from the vessel and ROV remained clearly present across the recording systems. Only the biological sound layer vanished from the water column, as though the entire ecosystem had simultaneously stopped transmitting life. Then the sound returned. No pursuit followed afterward. No predator appeared on the feed. But the scattering layer had now shifted nearly 70 meters deeper. The expedition did not classify the region as a dead zone. Oxygen levels remained stable. No signs of mass mortality appeared. The water simply felt as though living sound had been removed from it for a brief moment. Quietly, the technician marked a second timestamp inside the system log. This time, it was no longer an unidentifiable vibration. It was complete silence. If the organisms inside the trench were still alive, why had they all stopped making sound at the same moment? The scattering layer still remained beneath the Tonga Trench. It simply no longer occupied the place where it should have been. And while the expedition prepared to lower the ROV beneath the Thermocline, the first biological lights began appearing deep inside the dark water column. where the anomaly no longer seemed confined to sound alone. The ROV began descending beneath the thermocline shortly after the hydrophones recorded 14 full seconds of complete biological silence in the water above. Around 600 to 700 meters down, the ocean entered an entirely different state. Sunlight still existed somewhere far overhead, but only as a faint blue haze too weak to suggest either day or night. Water temperature dropped rapidly with every few dozen meters. Layers that had held near 11 degrees slowly vanished, replaced by colder water closer to 5, where the ROV's metal frame began contracting slightly under the growing pressure. The transition layer altered more than temperature. It changed the way sound existed underwater. Small vibrations from the steering motors no longer carried the same distance. Noise from the pressure hull sounded shorter now, duller, as if the surrounding water had absorbed most of the empty space around it. Even the tether dragging behind the vehicle lost its familiar resonance. Beyond the narrow cone of the ROV lights, the camera no longer saw open water stretching outward like it had above. Everything outside the beam collapsed almost immediately into dense blackness. As natural light nearly disappeared, small particles within the water column began revealing themselves. At first, they looked like dust catching the lamps. But the deeper the expedition descended, the more the crew realized they were no longer reading the ocean through horizons or terrain. From that point on, they began reading it through whatever drifted across the camera lens. Thousands of particles of marine snow reflected inside the white beam of the ROV. They fell slowly, sometimes sliding sideways before continuing deeper into the dark. Nothing moved chaotically. No strong currents crossed the water column. The entire layer felt denser, quieter, like a space stripped of almost all surface motion. These drifting organic fragments were the remains of life above decomposing tissue, waste matter, soft biological debris breaking apart over days before finally sinking this far down. In the absence of sunlight, marine snow became the continuous energy source sustaining the ecosystems below. The ROV recorded marine snow densities significantly heavier than previous survey zones, but the distribution was not entirely uniform. Some regions became so dense the floodlights turned them into pale curtains of underwater snowfall. Then, without warning, the particle density thinned dramatically, leaving clearer pockets of water between the drifting matter, as though something had slightly altered movement inside the column itself. At the time, the crew did not classify it as abnormal. Still, the sudden density shifts were quietly marked across the expedition data map. Then the first biological lights appeared in the darkness ahead. Not schools of fish, not even recognizable shapes. Only a few dim blue rings opening and vanishing inside the water, scattered beneath the thermocline among the falling marine snow, like interrupted signals cut short mid-transmission. The ROV drifted closer, revealing several Atolla jellyfish suspended inside the dark layer. Without bioluminescence, their bodies almost disappeared completely. The deep red coloration of their bells allowed them to vanish into water where red wavelengths no longer traveled. But whenever they reacted, cold blue rings of light immediately spread outward in concentric circles like alarm signals in the deep sea. Normally, The response appeared during predator attacks. This time, the camera recorded no predator at all. No large shadow crossed the frame, no strike, no visible hunting movement. And yet, the pulses continued emerging from below, one cluster after another, all spreading in nearly the same direction. The light revealed nothing moving through the darkness. It only revealed the path the disturbance had already taken. As the final rings faded, the camera began detecting longer structures suspended ahead. Giant siphonophores drifted through the midwater layer. Colonial organisms made of specialized zooids functioning together as a single living body. Their soft, living chains stretched through the darkness, while nearly invisible tentacles opened into the water to intercept smaller organisms drifting alongside the marine snow. The expedition noticed the colonies were not drifting randomly with the current. They maintained relatively stable positions within the nearly motionless water. Then the pressure sensor registered a slight vibration. Immediately afterward, the entire siphonophore colony contracted almost simultaneously. Tentacles vanished back into darkness in an instant reflex. No major current passed through the area. No object collided with the colony. The only change recorded in the data was a minor fluctuation in water pressure. From that moment forward, the expedition stopped focusing on the glowing organisms. They began focusing on the water between them. The ROV entered a region filled with scattered points of bioluminescence suspended among the marine snow. At first, nothing seemed unusual. Pale blue lights blinked open in the dark and vanished again in short cycles. But several minutes later, the clusters began disappearing layer by layer. Not a camera failure, not weakening floodlights. The lights shut down before the ROV even approached them. One of the biologists aboard quickly recognized the pattern. The shutdown wave always moved upward from below. Artola flashed and disappeared. Siphonophores contracted inward. Marine snow inside the affected region became noticeably thinner. Expanding pockets of darkness slowly opened through the water column vertically, as if the entire ecosystem were withdrawing from something ascending beneath the thermocline. The ROV slowed. The camera tilted deeper. For a few brief seconds, the expedition observed a region of water that appeared almost entirely empty. No particle reflection, no marine snow drifting through the lights, no bioluminescence, no silhouettes. The darkness did not resemble the shadow of a large body. It did not resemble image distortion or muddy water. It resembled a zone where every biological signal had temporarily retreated before the camera arrived. The pressure sensor vibrated again, very faint, not strong enough yet to qualify as a pulse. Then, without warning, every atoll above the empty region illuminated simultaneously. Blue rings spread rapidly across the water, cascading through the darkness overhead like a chain reaction from an ecosystem that had sensed the same disturbance at once. The expedition never saw a creature. No collision, no pursuit. Only an entirely vacant section of water beneath the thermocline, while synchronized biological reactions spread upward above it. The ROV held position inside the transition layer instead of descending further. Below remained absolute darkness. Above, vertical migration patterns began changing rhythm. Midwater fish that should have continued descending during the nighttime cycle gradually slowed near the edge of the thermocline. as though the entire water column had begun rejecting the depths beneath it. (11:18 M). Far above the ocean surface, the sun approached its highest point of the day. But between depths of 780 and 940 meters along the northeastern slope of the Tonga Trench, light no longer existed as direct illumination. It survived only as a faint pressure filtering downward through layers of cold, dense water. By then, the expedition had drifted more than 60 kilometers beyond the continental margin. Marine snow still drifted slowly across the camera frame, though at lower density than earlier recordings. The water column itself felt unnaturally still. Tracking systems showed biological movement density nearly 25% below regional baseline data, as though part of the ecosystem activity inside this depth range had disappeared from the ocean's normal rhythm. After recording the empty region beneath the Thermocline earlier in the descent, the expedition chose not to continue deeper. Instead, the ROV stabilized just above the midnight zone. Passive sonar maintained slow, vertical sweeps to monitor migration behavior. The mission was no longer about discovering an unknown organism. The objective now was to determine whether the anomaly below the water column was altering biological migration cycles themselves. More importantly, the crew wanted to know which species would react first if the pressure pattern truly was changing. Tracking systems focused on 3 dominant groups within the scattering layer: lanternfish, hatchetfish, bristlemouth. Tiny fish nearly invisible to the human eye, yet central to the biomass structure of the deep ocean. If the rhythm of the scattering layer shifted, these species would reveal it first. Lanternfish appeared on sonar as soft, moving clusters of reflection. Under normal conditions, the schools would continue descending as sunlight intensified overhead. It was part of Deal vertical migration, the largest biomass movement on Earth, repeated daily between deep and shallow water. During daylight, they descended to avoid visual predators. At night, they returned upward towards zooplankton-rich layers. Photophores lining their undersides allowed them to blend into faint overhead light through counter-illumination while maintaining cohesion inside near-total darkness. But that day, the scattering layer stopped descending. A large portion of the lanternfish schools stabilized near 820 meters. No signs of panic appeared, no chase patterns, no collapse. Sonar detected no large predators approaching from below. The fish simply slowed, maintained formation, then collectively turned sideways within the water column, and instead of continuing downward, they began ascending toward brighter water. The behavior contradicted normal survival logic. The higher they climbed, the easier their silhouettes became for visual predators above to detect. Yet the schools maintained near-perfect cohesion while changing direction. It did not resemble panic. It resembled refusal. A collective refusal to descend beneath a threshold the scattering layer seemed to recognize before the expedition did. As the lanternfish altered orientation, other reflective signals inside the water column began shifting as well. Hatchetfish emerged near the edge of the camera frame, their bodies thin and flattened like silver blades. In the exposed midwater environment where hiding places did not exist, body orientation meant survival. Even a slight misalignment against the weak light above could expose their silhouettes to predators instantly. Normally, Hatchetfish maintained perfect angles relative to the faint illumination overhead. Now many individuals tilted downward nearly 20 degrees. Not hunting posture, not migration posture. They looked as though they were directing their entire sensory attention toward the water beneath the scattering layer. Passive sonar still detected no predator, no major displacement, no strong turbulence. Only the synchronized reorientation of an entire mid-water species toward the same direction. Then the bristlemouth cloud at the edge of sonar began contracting inward. These tiny organisms typically existed in immense densities throughout the twilight zone, relying almost entirely on synchronized movement to maintain position within the water column. Over a span of seconds, the density of the entire biomass cloud increased noticeably. The school shifted direction almost simultaneously, as though it had sensed a weak displacement moving through the surrounding water. At that moment, the pressure sensor still registered nothing, no chase signal, no large organism, no current strong enough to trigger a chain reaction like this. And yet the entire scattering layer had already begun changing rhythm. Migration species reacted first. Camouflage species adjusted orientation next. Then schooling density compressed inward like a collective anticipation mechanism. Only afterward did the pressure sensor finally vibrate. The fluctuation lasted less than 1.5 seconds, too brief for tectonic activity, inconsistent with current shear, no match for cavitation from the ship above. More importantly, the fluctuation appeared nearly 5 seconds after the organisms had already begun changing direction. For the first time, the pattern became unmistakable. Bristlemouth compressed inward first. Hatchetfish tilted downward. Lanternfish reversed direction. Bioluminescence gradually faded across the frame. The migration layer withdrew upward. Only then did the pressure sensor register fluctuation. The expedition began realizing their instruments were no longer detecting the anomaly first. The ecosystem itself had become the real sensor network of the trench. These small organisms inside the scattering layer were sensing something mechanical instruments could only recognize several seconds later. To eliminate any interference from the propulsion system, the ROV switched into drift mode. Thrusters dropped to minimum output. Passive sonar continued tracking the migration layer in near total silence. Then the vertical reversal began. Thousands of lanternfish simultaneously swam upward toward brighter water. A nearly irrational survival decision for mesopelagic species. Still, the entire layer continued rising. Marine snow beneath the camera frame began shifting direction slightly, as though a large mass of water were moving upward from below. The scattering layer slowly expanded into a curved opening. Not a school collapse, not a panic spread. It resembled a corridor forming inside the water column. No predator appeared, no attack followed. Only the entire migration layer opening itself apart before withdrawing upward. The pressure sensor vibrated harder this time. At the exact same moment, every trace of bioluminescence inside the camera frame shut off simultaneously. For nearly 5 seconds afterward, nothing remained except marine snow falling through the dense darkness of the midnight zone. Then, from somewhere beneath the frame, a deep, low-frequency vibration began traveling upward through the water. It did not sound like noise. It felt like pressure in motion. At 13:42 in the afternoon, the ROV remained stationary inside a narrow depression nearly 14 kilometers offset from the main axis of the Tonga Trench. Depth fluctuated between 910 and 980 meters. Water temperature held steady at roughly 4 degrees Celsius. The current had almost completely stalled, allowing marine snow to descend in dense vertical columns far thicker than those observed in the upper layers. Under pressure exceeding 90 atmospheres, the outer hull of the ROV emitted faint contraction sounds in slow repeating intervals as the deep water compressed against the frame. Following the vertical reversal within the migration layer above, the scattering layer continued retreating upward in thin fragmented bands. The expedition did not descend immediately. The ROV was deliberately held at the exact depth where most biomass appeared unwilling to move, below approximately 970 meters. The original objective was simple: determine whether this was merely a localized migration anomaly. But the longer the vehicle remained suspended there, the more the sensation of a true ecological boundary began to emerge. During the first few minutes, the passive hydrophones still captured faint biological traces drifting down from the upper water column. Far above, turbulence from lanternfish produced low trembling bands that nearly dissolved into the background water. Occasionally, slow squid movement appeared at long range. A handful of isolated crustacean microclicks still surfaced inside the marine snow layer. The soundscape had not vanished entirely, but it no longer carried the dense living texture typical of the Mesopelagic Ocean. Then, in less than 8 seconds, the entire biological acoustic layer disappeared. There was no fade out, no gradual weakening with distance. The sound did not thin in stages the way biomass normally fades as organisms migrate out of range. It was removed from the water column almost instantly, as if the entire section of ocean had been muted simultaneously. The hydrophone itself continued functioning normally. The ROV still recorded faint tether vibrations inside the nearly motionless current. The slow metallic contractions of the pressure-stressed hull remained audible at regular intervals. Even tiny marine snow particles striking the exterior shell registered as isolated pulses. Only the biological layer vanished completely. This silence was different from the scattered acoustic pockets detected earlier. The ocean had not become physically empty. Water still moved. Pressure still existed. Marine snow continued falling through the camera frame like fine snowfall descending through kilometers of darkness. But the biological presence of the water had disappeared from the expedition's passive listening systems entirely. Several minutes later, the forward camera detected slow movement at the edge of the light. A lone vampire squid hovered almost motionless within the water column. The species did not truly belong to modern squid in the conventional sense. Its anatomy carried older traits positioned somewhere between squid and octopus, adapted for oxygen-poor layers where most cephalopods struggle to maintain stable energy exchange. At this depth, vampire squid survive through an almost extreme strategy of energy conservation. They do not pursue fast-moving prey. Instead, 2 long feeding filaments collect detrital matter and falling marine snow from above, converting dead organic material into a stable energy source within the cold, nutrient-poor water. But the individual in front of the camera was not feeding. Its feeding filaments had been fully retracted. Dark webbing tightened around the central body. It did not drift naturally with the current, the way the species normally suspended itself in open water. Its entire posture suggested silent, defensive behavior. For nearly 12 seconds, the vampire squid remained fixed in place, as though waiting for some signal emerging from the darkness below the camera's range. Then, a brief cloud of bioluminescent mucus ejected behind the body. Immediately afterward, the animal retreated upward in slow but decisive contractions, disappearing into the dark water above the ROV. What drew the expedition's attention was not the creature itself. Vampire squid are among the most energy-efficient organisms in the deep sea. They avoid unnecessary movement whenever possible. For an individual to stop feeding, retract its filaments, and abandon a water layer suggested a response severe enough to override the energy preservation logic governing nearly its entire life cycle. The forward imaging sonar began scanning deeper beneath the ROV. The display returned an extended, empty region below, with none of the familiar biological reflections normally present in deep water. No plankton scatter, no fish density, no gelatinous drift. Not even the soft current interference that typically forms faint distortion layers in open ocean environments. The water below did not resemble a naturally empty space. It resembled a region where biological signals failed to return to the sonar system at all. The expedition avoided calling it a dead zone. No data suggested oxygen collapse or chemically lifeless water. Marine snow still existed. Pressure remained stable. The water column showed no abnormal stratification, but organisms appeared unwilling to enter the area. When data from earlier Phi IDs was compared again, reactions that had once seemed isolated began aligning into a clearer pattern. Lanternfish halted migration above the layer. Hatchetfish changed direction immediately before deeper descent. Bristlemouth clustered together near minor pressure fluctuations. Vampire squid retreated upward, despite the absence of any visible predator. Below them, the sonar void remained empty. Species with entirely different survival strategies were all avoiding the same depth boundary. It was not a light boundary, not terrain, not a current barrier. It resembled a behavioral boundary the ecosystem had recognized long before the expedition understood it existed. The ROV later deployed a passive pressure marker beneath the acoustic void. The device transmitted only minimal telemetry related to pressure and movement, avoiding active interference within the water column. The marker descended approximately 31 meters below the ROV before the signal vanished instantly. No warning, no gradual signal degradation. The telemetry was severed cleanly, as though the device had crossed an invisible plane beneath the dark water. 3 seconds later, a pressure pulse moved past the ROV. Marine snow that had been falling vertically suddenly swept sideways in opposite directions, as though something enormous had displaced the water column while passing through. The camera detected no silhouette, no shape, no visible body. Only water deforming into a faint corridor inside the darkness. The hydrophone then registered an extremely low vibration, repeating once every 19 seconds. After the third cycle, the sonar void beneath the ROV began slowly widening layer by layer. The expedition still had not seen the source, but for the first time since entering the trench, the silence had developed a rhythm, and from that moment forward, the anomaly no longer existed only inside the soundscape. It had begun creating its own space, a black corridor where almost nothing alive continued descending deeper into the ocean below. At 15:06 in the afternoon, the ROV descended through water layers between 1,020 and 1,180 meters, leaving behind the previously established acoustic void and entering a narrow passage positioned between towering walls of ancient basalt stacked along the geological structure of the trench. The space ahead did not open outward in the familiar scale of the deep ocean. Instead, it was constrained by two elongated geological faces that formed a natural corridor between 400 and 600 meters wide, extending nearly 11 kilometers along the continuously descending slope of the trench floor. Environmental data recorded an abnormal reduction in particle density. Current flow had nearly vanished entirely. Current measurements indicated a state approaching absolute stillness. Oxygen concentration measured lower than surrounding regions, though not low enough to explain the near-total disappearance of biological activity. Following the repeating 19-second vibration cycles and the expanding sonar void detected above, the entire migration layer tracking strategy collapsed. The ROV redirected downward through the confirmed empty region itself, rather than continuing to follow the horizontal migration flows higher in the water column. The objective was no longer to track biological movement across the trench. It was to determine whether the acoustic void existed only as a localized anomaly, or whether it reflected a structure extending along the geography of the trench itself. As the ROV advanced deeper into the corridor, the transmitted imagery still showed marine snow descending slowly through the water column. But the defining feature was not what appeared within the frame. It was the systematic absence of movement that normally defines deep-sea life. No isolated movement from small fish, no drifting gelatinous organisms, no elongated siphonophore structures, no micro-disturbances from crustaceans, no scattering streaks produced by microfish crossing through the ROV light. Marine snow continued falling in almost perfectly straight trajectories, uninterrupted by biological vortices, undisturbed by passing organisms, and absent the faint particulate distortions that appear even within the quietest deep-water environments. This did not resemble an ordinary low biomass region. It resembled a volume of water that had been entirely cleared of organic motion, under oxygen conditions that remained below average but far from extreme. The presence of hypoxia-tolerant species, detritivores, or drifting gelatinous organisms would still normally be expected. None appeared inside the corridor. The boundary of the phenomenon only became fully visible when a large, slow-moving organism emerged near the outer edge of the dark passage. The individual belonged to the giant phantom jellyfish, Stygiomedusa gigantea, one of the rarest deep-sea jelly species ever directly observed. Its bell structure exceeded a meter in diameter, while four ribbon-like oral arms extended more than 10 meters into the water column. Its gelatinous body remained nearly transparent, adapted for extremely low-light environments. The species does not actively pursue prey, instead drifting with surrounding water movement. Under normal conditions, its drift direction reflects even the smallest fluctuations within the current field. But near the edge of the corridor, the jellyfish began displaying a distinct directional deviation. Its bell rotated slowly through natural pulsing cycles. Yet the organism never crossed into the dark central region of the passage. The long oral arms remained suspended along the boundary itself, never extending inward despite current meters recording almost no directional flow whatsoever. After several moments, the entire body slowly rotated away and drifted back toward the upper water layers, as though the boundary was not empty space, but an environmental condition that had to be avoided. From that observation, the phantom jellyfish became the first biological indicator of a boundary that sonar itself could not detect. An organism entirely dependent on water movement refused to enter the central region at all, a biological contradiction strong enough to transform the corridor from an unusual environment into something behaving like a structured zone. As image data was reviewed again, the phenomenon no longer appeared isolated. Other gelatinous organisms began displaying the same avoidance behavior. Comb jellies approached the edge of the corridor before slowly changing direction. Siphonophore fragments failed to extend into the dark center, dispersing instead along the outer margins. Larvation colonies maintained a stable distance from the central axis. Smaller gelatinous drift masses appeared subtly deflected moments before reaching the corridor core. Nothing crossed the center. The result formed a community-scale avoidance pattern among gelatinous organisms, an entire soft-bodied ecosystem responding in synchrony to the same invisible boundary. CTD data later confirmed that dissolved oxygen within the corridor remained lower than the surrounding baseline, but still far above the thresholds associated with conventional oxygen minimum zones documented in deep ocean studies. Under such conditions, ecosystems normally retain at least some degree of activity. Hypoxia-tolerant fauna, detritus feeders, scavengers moving through sediment currents. Yet inside this corridor, no feeding traces appeared, no scavenger activity, no signs of biological decomposition being exploited, no gelatinous drift crossing the center. Physical conditions revealed no dramatic change in temperature or current flow. But biological density collapsed suddenly and uniformly, creating the impression that this was not merely oxygen-poor water, but a fundamentally different environmental state. As the ROV approached the central axis of the corridor, light behavior itself began to change. Marine snow no longer reflected brightly within the beam as it had along the edges. Instead, the particles seemed absorbed into an incomplete visual space. The dark region stretched into a clearer and more stable corridor shape. It no longer resembled the fragmented acoustic voids encountered earlier. It had become a continuous structure embedded directly within the trench terrain. Pressure rose slightly across the sensors, though not enough to create meaningful mechanical stress on the ROV hull. Along the outer margins, gelatinous organisms continued maintaining the same avoidance state. Then, as the camera rotated toward the central axis, the marine snow shifted sideways. The falling particles separated into two distinct lateral streams along both sides of the corridor. Current meters detected no corresponding hydrodynamic change. There was no silhouette, no shape, no visible body moving through the frame. Yet the entire particle field divided apart, as though something had passed through earlier and left behind a region where suspended matter could no longer maintain its natural distribution. The sensation of observation no longer revolved around watching something appear. It shifted toward the possibility that something had already moved through the corridor, leaving behind no visible trace except the deformation of environmental behavior itself. The corridor was no longer perceived as empty water. It had begun to resemble a path the deep-sea ecosystem had learned to avoid. At depths ranging between 1,240 and 1,410 meters, the ROV maintained a stationary position along the edge of the black corridor, where the boundary between the particle displacement zone and the outer layer became more defined with every observation cycle. The timestamp registered at 1711 during the transition towards surface twilight far above, though all remaining traces of sunlight had long since been erased by the mass of deep water below. At this depth, the concept of day and night no longer existed. Only pressure gradients and the shifting density of suspended particles remained. The expedition did not continue pursuing the disturbance observed earlier. Instead, the ROV held position along the boundary itself, reducing thruster output to its minimum state to eliminate turbulence, while the cameras remained fixed on the vertical seam where marine snow had begun separating to either side, as though the drifting material was reorganizing its own trajectory through the water. Along the outer boundary, particle density slowly increased again. Gelatinous organisms appeared in greater concentration than inside the corridor core, forming what looked less like a population center and more like a delayed biological response to water that had recently been distorted. No pursuit maneuvers were initiated. Observation alone continued, focused entirely on whether the ecosystem would repeat the same reactions in recognizable cycles. And within that near motionless stretch of water, the first points of light did not emerge as anything beautiful. They appeared instead like isolated pulses inside a water column, waiting for something deeper to begin activating itself. Within the dark layer slowly returning to equilibrium, the comb jellies showed the first visible response. These ctenophores, propelled through the water by rows of delicate cilia known as catenas, normally produced shimmering patterns whenever the ROV lights struck their transparent bodies. And under many deep water conditions, they were also capable of generating bioluminescence through internal mechanisms. But at this moment, the illumination no longer behaved randomly. At first, only a few individuals lost their glow, as though some internal signal had suddenly been interrupted. Then the blackout spread vertically through the water column, not according to distance from the ROV, nor according to organism density, but along a slow-moving curved path, drifting upward through the dark. The extinguishing did not happen in fragments. It resembled synchronization triggered by an environmental condition that still could not be seen. The comb jellies no longer functioned as aesthetic displays of deep-sea light. They became biological sensors, reflecting changes in the surrounding water through the disappearance of their own luminescence. And as their light faded, neighboring clusters immediately repeated the same sequence, as though the entire column of water had begun receiving a shared signal whose source remained unidentified. From that point forward, the flash chain became increasingly visible within the observation structure itself. Bioluminescent organisms no longer behaved as isolated lights scattered through the abyss. They transformed into linked reactions, moving in sequence. One region would suddenly ignite for several seconds before shutting off completely. Moments later, another cluster directly above it repeated the exact same pattern. The effect spread vertically through the water column like a biological domino chain, though no direct influence from the ROV was ever recorded. The light was not reacting to the observing vehicle. It behaved more like an endogenous signaling system within the ecosystem itself, responding to some deeper displacement, moving invisibly through the environment. In the deep sea, where bioluminescence normally serves survival functions ranging from defense to predation to communication, the expanding chain of light no longer carried any aesthetic meaning. It became a temporary map, tracing the path of a disturbance traveling through the water long before any physical form could be confirmed. As the flash chain widened spatially, an ecological contradiction began to emerge. Regions that normally maintained high predator density no longer sustained ordinary activity. Crystal jellies, with their transparent bells and continuous pulsing contractions, appeared near the edge of the illuminated zones. But instead of drifting laterally along the particle field as they normally would, they began ascending upward, as though being drawn out of the ecological balance axis entirely. The shift did not resemble panic. It reflected an environmental condition powerful enough to redefine even the passive drift behavior of fragile gelatinous organisms. At the same time, deep-sea dragonfish predators equipped with rows of photophores and a glowing chin barbel used to attract prey failed to exploit the increasing concentration of organisms surrounding the flash chain. Contrary to normal ecological expectations, they never entered the spreading light field. Sonar traces of their presence gradually disappeared, as though the entire movement network had withdrawn from the area. There were no hunting events, no pursuit patterns, only the synchronized absence of both predator and prey inside a region seemingly activated by an unknown force. The ecosystem here no longer operated through predation logic. The entire predator-prey structure appeared to be retreating together from a pressure event that still had not revealed itself. As both ecological extremes withdrew from the observation zone, attention shifted toward the space between them. Biological reactions continued appearing in synchronized layers. Jellyfish shut down in sequence. Comb jellies continued collapsing along the same curved blackout path established earlier. Marine snow began changing direction subtly, as though local currents were being bent sideways, while scavenger density in the lower layers rose abnormally. Forward sonar registered a displacement region moving through the water column without any visible outline. It generated no direct biological response, yet left behind a zone of lower reflective density, as though the water itself had briefly opened before sealing shut again. The expedition made no conclusion regarding the presence of a specific organism. The only confirmed observation was that a region of water was moving differently from every surrounding current, and that all biological reactions were reorganizing around its trajectory. As the displacement drew closer, the speed of the flash chain increased noticeably, as though the entire ecosystem was entering a final synchronized state before a larger pressure event arrived. The peak occurred when the shutdown wave expanded far enough for the ROV to lose all visual reference for nearly 9 continuous seconds. No bioluminescence remained, no particle reflections, no silhouettes capable of defining space. Every visual signal vanished completely, leaving only telemetry data showing slight pressure, increases pulsing in small, rhythmic intervals. Then, the biological light slowly returned. A single comb jelly appeared directly in front of the camera, close enough for its transparent body to consume the entire frame. The rows of setaens were rigid in a natural contraction, its soft anatomy bent sharply to one side for a fraction of a second, as though the entire organism had just been compressed by a force that never made physical contact. No object appeared nearby. No predator silhouette emerged. Only the pressure data indicated that the surrounding water had momentarily compressed into an asymmetrical structure around the organism itself. The timestamp was flagged immediately within the expedition logs. From that moment onward, the question no longer centered on which creatures were producing light. It shifted toward the nature of the environment itself, toward the possibility that some force existed capable of compressing water around living bodies without leaving behind any visible physical trace. After this sequence, bioluminescence was no longer treated as isolated flashes of deep-sea light. It became understood instead as a distributed warning system embedded throughout the ecosystem, where illumination appeared only to announce the approach of its own disappearance. And at the next depth layer of the descent, scavengers would begin arriving before any biological remains had even fallen into the water, as though the ecosystem had already learned how to detect a pressure event before it fully arrived. At 1902, between depths of 1,520 and 1,840 meters, along the sloping edge of the lower bathypelagic zone, gradually descending toward the abyssal transition, the surrounding water entered a brief period of stability before pressure oscillations began returning again, like restrained breaths compressed beneath the column of the sea. Temperatures in the region approached 3 degrees Celsius. The sparse bioluminescence lingering from the upper layers diminished even further, leaving behind an environment where optical signals no longer functioned as the primary navigational structure. Following the flash chain and the visual blackout recorded during the previous stage, the observation systems shifted focus away from luminous anomalies and toward the lower layers, where scavenger activity had begun increasing in organized patterns. In the deep ocean, energy rarely originates from living systems themselves. It descends instead through organic fallout drifting from the waters above, and scavenging amphipods serve as one of the central links within the detrital network, where nearly every biological trace can become a rare nutritional resource. Under ordinary conditions, scavengers appear only after death events occur, functioning as one of the ecosystem's inevitable responses. But here, the observed sequence no longer followed that order. Signals from scavenger populations began forming inside a region of water that remained completely empty. At this depth, hundreds of giant amphipods gathered around a space containing no recognizable signs of organic remains. These crustaceans normally specialize in consuming biological debris, concentrating around carrion or descending food falls from the upper layers. Under standard deep-sea conditions, their behavior is triggered by extremely faint chemical gradients, especially amino acid traces released by decomposing tissue signals. Their chemoreception systems can detect even within an ecosystem nearly devoid of excess energy. But within the observation frame, They attached themselves to nothing. No feeding behavior appeared, no competition emerged. Instead, the entire swarm moved in slow orbital patterns, as though maintaining a prolonged state of anticipation around the empty water itself. Their presence no longer represented a reaction to death. It became an ecological indicator of something not yet formed but already sensed, as though the ecosystem was responding to a structure preparing to emerge rather than to an event that had already occurred. When expedition analysts compared the timestamps between amphipod aggregation, pressure telemetry changes, and the moment the first bodies appeared within the water column, a striking temporal anomaly emerged. The scavenger swarm formed 6 to 14 minutes before any carcasses entered the frame. Under ordinary ecological logic, carrion must exist first to generate the chemical gradients that attract scavengers. Here, that sequence had clearly reversed itself. The water remained empty. No carcasses, no decomposition, no visible mortality event. The anomaly created a distortion in necrophagic behavior itself, where scavengers no longer appeared to respond to the result of death, but to conditions capable of producing it. And while the amphipod swarm maintained its rotating formations, the first scattered movements finally began descending from the darkness above, breaking the stillness of the column. Roughly 11 minutes after the amphipods first gathered, bodies from multiple species began entering the observation frame. Lanternfish, bristlemouths, and small squid descended in scattered waves. Not as dense food falls typically observed in deep water ecosystems, but as though each individual had independently ended its life cycle somewhere higher in the column before sinking into the depths below. There were no signs of pursuit. No major turbulence, no predator silhouettes appeared in sonar or camera systems. The bodies showed no bite marks, no missing tissue, no injuries associated with predation. Their structures remained almost entirely intact, as though no violent physical interaction had ever occurred. The absence of direct predatory evidence pushed the entire observation in another direction, entirely toward the possibility that death here was not being caused by biological interaction, but by some deeper mechanism acting directly upon the water column itself. And while the amphipods continued circling slowly through the empty space, several squid specimens began displaying abnormalities that were increasingly difficult to explain. Some small squid appeared with their mantles contracted in unnatural ways. Tissue surrounding the statocyst regions showed asymmetrical damage, while outer structures like denticles remained untouched, free from tearing or mechanical trauma. No bite patterns, no decomposition, no evidence of direct predatory interference. Rather than reaching conclusions, the expedition limited the observation to hypothesis alone. The distortions could potentially relate to pressure instability or some physical disturbance moving through the water column, affecting biological structures in ways that left behind none of the conventional traces associated with predation. As more bodies descended, the reaction spread beyond the amphipod population into multiple ecological layers throughout the surrounding system. At the edges of the frame, cusk eels appeared earlier than expected. Scavenger shrimp density increased sharply, while gelatinous organisms began retreating upward, through the water as though withdrawing from the lower zone entirely. None of these species reacted identically, yet all displayed behavioral shifts before any clearly measurable pressure pulse was detected. The ecosystem no longer behaved through simple avoidance. It had entered an anticipatory state, where organisms seemed to prepare for an event that had not yet occurred, but was already being sensed environmentally. A living lanternfish appeared near the edge of the swarm, its movements weak and unstable against the current. As the ROV focused on the individual, no predator presence appeared anywhere within sonar range. Yet the fish suddenly began convulsing violently. Physiological collapse spread rapidly through its body, as though its internal equilibrium system had failed without warning. The event was recorded as potentially consistent with swim bladder collapse under pressure instability, though no definitive biological conclusion was made. For a brief moment, hemorrhaging appeared around the eye before all biological activity ceased almost instantly. The amphipod swarm reacted immediately. They surged inward from the darkness with almost no delay, as though the timing had already been synchronized to some larger environmental cycle long before the death occurred. 3 seconds later, the entire scavenger network converged on the fall point without hesitation. There was no exploratory behavior, no verification, only instant response, operating more like a mechanism programmed by environmental conditions than by opportunistic feeding. At that exact moment, the hydrophone recorded the strongest pressure pulse since the expedition began. The entire frame trembled slightly. Marine snow across the lower layers shifted direction as though displaced by an invisible force moving through the water. And immediately after the pressure wave passed, every scavenger stopped. Not in reaction to light, not because of the observing equipment, but as though something had just moved beneath the entire ecosystem. The deep ocean no longer felt empty. It carried the sensation of organized waiting, where silence was no longer the absence of sound, but a coordinated reduction of presence before another pressure event passed through the water column. And within that pause, the remaining question no longer centered on how death had occurred, but whether the ecosystem was reacting to death at all or reacting instead to whatever was creating it. At 9:14 p.m., after more than 16 continuous hours operating inside the pressure-darkened trench, the expedition lowered the ROV deeper into the upper abyssal transition zone along the southeastern trench slope, where the depth had already passed 1,980 meters and was steadily approaching 2,240. The terrain no longer descended in steep walls like the upper layers. Instead, it opened into broad sediment basins, flatter and wider, yet unnaturally still. Water temperature dropped close to 2.7 degrees Celsius. Pressure exceeded 220 atmospheres. Almost no measurable horizontal current remained. Marine snow still drifted through the water column, though no longer in dense clustered clouds. The particles were finer now, more concentrated, lingering longer between descent and suspension, like biological dust trapped in a state between falling and stillness. Following the final pressure pulse from the previous stage, scavenger activity had nearly vanished. Gelatinous organisms withdrew upward out of the basin. The acoustic floor collapsed into near total absence. By this point, the expedition was no longer focused on locating a specific predator within the frame. The question had shifted into something deeper. How were the organisms here detecting the pulse before the environment visibly changed? In a depth where light had almost completely lost its purpose as illumination, certain species still maintained extreme visual systems capable of detecting the weakest remaining signals in the water. It was here that 3 barrel eyes appeared, nearly motionless inside the thin marine snow layer. Their transparent cranial dome and tubular light-sensitive eyes had evolved specifically for upward observation, detecting silhouettes and faint biological movement drifting from the water column above. Their entire survival strategy depended on vertical awareness, a low-energy form of surveillance in the deep dark. But the anomaly was not their presence. It was the direction they were looking. All 3 individuals rotated their eyes downward into the abyss below. None maintained their normal upward orientation. No feeding posture, no prey tracking from above. A species evolved to watch the water overhead was now focusing its entire sensory attention beneath itself, as though the most important signal in the environment no longer came from the upper layers at all. Several seconds later, the ROV's LiDAR system began detecting subtle irregularities within the marine snow density. Not light distortion, not sediment plumes, not current fronts. Instead, long zones of faint compression drifted slowly through the basin, stretching for tens of meters without defined edges. Like sections of water undergoing microscopic pressure deformation, they resembled pressure shadows, regions where particle distribution had been compressed and displaced in ways almost too subtle to visualize directly. More disturbing was the sequence itself. The barrelies always reacted before the pressure shadow became visible in the data. The eyes rotated downward first, the bodies froze immediately after. Only then did the marine snow begin to deform. The pattern suggested the anomaly was being detected biologically, long before instruments could confirm it visually. At depths where hydrostatic pressure itself became a survival signal, sensory systems like lateral line detection and pressure-sensitive orientation appeared capable of perceiving displacements that human technology was only beginning to recognize. Farther across the basin, spookfish emerged like a second confirmation of this sensory hierarchy. With tubular eyes adapted for extreme low-light sensitivity, some even using rare reflective optical structures to maximize incoming signals. The species represented another visual strategy for surviving inside abyssal darkness. Yet their behavior reinforced the same conclusion. As the pressure shadow drifted through the water column, the spookfish did not panic or flee. They never crossed through its center. Instead, they curved around the invisible zone in smooth arcs, maintaining remarkably stable distances as though tracing the outline of a sensory boundary suspended in the water itself. The barrelies watched downward. The spookfish circled around. No direct contact was necessary. The pressure structure alone was enough to alter the entire sensory logic of the surrounding ecosystem. To eliminate the possibility of a purely behavioral anomaly, the expedition initiated a passive drift experiment. All thrusters were shut down completely. An ultralight sensor ribbon was released freely into the nearly currentless water column. Current meters still returned readings close to zero, but the ribbon began to tilt. Marine snow shifted direction slightly. There was no true current, no visible turbulence, only a minute pressure gradient, too subtle to observe directly, yet strong enough to pull passive objects off alignment. It became the first direct evidence that the anomaly was not limited to animal behavior. It was physically affecting the water column itself. Then one of the pressure shadows moved closer to a solitary barrel-eye. This time, the entire reaction sequence unfolded faster. The eyes snapped downward, the body froze completely. An almost invisible hollow of water passed beneath it. For roughly 2 seconds, the marine snow inside that zone disappeared entirely before reforming again. Immediately afterward, the barrel-eye accelerated upward with an energy output completely abnormal for a species evolved around movement conservation. Pressure telemetry registered a sudden pressure drop, not a spike, but a brief depression that recovered almost instantly. Seconds later, every spookfish within sonar range vanished. A temporary conclusion slowly began forming within the expedition data. The organisms here were not merely avoiding sound or light, they were avoiding shapes of pressure moving through the water. And when even species evolved to observe the world above began directing their senses downward into the deeper abyss, the question was no longer where the predator was. It was what was rising from depths below, where vision itself may have become only the first layer of warning. At 11:02 p.m., between depths of 2,480 and 2,810 meters, the expedition lowered the ROV onto a broad sediment plateau bordering the abyssal plain, where the seafloor had been buried beneath dense layers of organic silt accumulated over thousands of years. Water temperature remained near 2 degrees Celsius. Current movement had almost completely disappeared. Fine suspended sediment compressed visibility into a dim haze, where even the smallest movement threatened to disturb the entire benthic landscape. Following the brief pressure shadow event and the anomalous pressure drop recorded in the upper layers, observational focus shifted fully toward the benthic ecosystem. If something moving through the trench was truly creating physical displacement within the water itself, then organisms dependent on mechanosensory detection would likely perceive it more clearly than anything still relying on vision. The ROV slowed to minimum velocity. Lights were dimmed. Every system avoided disturbing the sediment floor, and inside that near motionless abyss, the seafloor revealed a predator field unlike anything previously observed. More than 20 tripod fish stood scattered across the sediment plain like living structures anchored upright into the mud. Their elongated fin rays had hardened into support limbs, elevating their bodies above the soft bottom while consuming almost no energy. It was a perfect abyssal survival strategy, where calorie conservation mattered more than pursuit. Rather than chase prey, they remained still, using sensitive feelers and vibration detection systems to sense mechanical changes within the near bottom water column. But the anomaly was not their presence. Every individual faced the same direction, not toward current flow, because almost no measurable current existed here. None displayed feeding posture, no strike behavior, no relocation. The entire predator field stood motionless as though listening to a disturbance traveling through the deep sediment below them. At the edge of the plateau, a cluster of deep-sea sea cucumbers slowly entered the observation zone. These detritivores normally moved only to filter nutrients from the seafloor and rarely reacted to predatory signals. This time, The entire group changed direction simultaneously before reaching a 70-meter strip of sediment. No visible predator appeared. No displacement strong enough to physically force movement existed. They simply avoided the region as though that section of seafloor had become an invisible boundary. For the first time, the anomaly no longer seemed limited to the water column. It was directly affecting the soft sediment ecosystem itself. Then the seafloor began to tremble. Not a seismic shock, no widespread vibration, no shifting cliffs, no major sediment plume. Only brief, rhythmic pulses, repeating in intervals, as though a localized pressure field was sweeping along the sediment water interface itself. With each pulse, the tripod fish lowered their bodies closer against the fin supports. Their sensory rays vibrated intensely. The sea cucumbers reduced nearly all feeding movement. Fine sediment lifted slightly before settling back down again. There was no panic. Only organized biological reaction to a mechanical signal the expedition still could not see. Then the pulses intensified. One tripod fish near the center of the field abruptly abandoned its primary survival strategy. Its sensory rays trembled violently for several seconds. The support fins folded inward. It left its position. Seconds later, the entire field withdrew from the sediment plain simultaneously. No pursuit, no revealed enemy, no chaos. Only a collective abandonment by some of the most energy-efficient predators in the abyss. Their former positions remained behind as shallow impressions in the empty mud. The sea cucumbers along the perimeter stopped feeding entirely. Then, the marine snow above the plain vanished across a sharply defined region near the seafloor. An elliptical void appeared, particle-free, as though the seawater itself had been compressed out of its normal structure. No silhouette, no shadow. No biological form emerged, only the shape of absence remained. For the first time, the void was no longer suspended in the water column. It had descended to the sediment floor itself. And if even the motionless hunters were abandoning their hunting grounds, then whatever was moving through the abyss below may not have hunted through speed at all, but through pressure itself. At 1:26 a.m., as the ROV descended through depths between 3,020 and 3,380 meters, the expedition entered a basin noticeably darker than the layers above, where the water column had shifted into an expanded low-oxygen zone. Bioluminescence no longer appeared in flowing chains of movement like it had higher in the trench. Now it surfaced only in scattered flashes between the dense pressure of the surrounding water. Vertebrate predators had become rare. The water column grew quieter, though the silence was not entirely still. Fine layers of marine snow drifted slowly downward through the dark, forming thin streams of organic matter that resembled biological dust sinking through a space that felt almost suspended in place. After the tripod fish abandoned the sediment plain above, the expedition now entered a region inhabited by organisms built around extreme energy conservation, where survival no longer depended on pursuit, but on living slower than any ecosystem above it. Within that oxygen-poor darkness, the vampire squid became the dominant organism across the basin. It was not an active predator, nor a high-speed hunter. Its body was adapted for low oxygen survival through minimal movement, using long, delicate filaments to gather marine snow, organic debris, fecal pellets, and tiny zooplankton drifting through the water column. It existed like a floating energy collector, representing one of the slowest survival strategies anywhere in the deep sea. Which meant that if even these animals were beginning to alter their behavior on a large scale, then the disturbance below could no longer be dismissed as a localized anomaly. The ROV quickly recorded dozens of vampire squid drifting throughout the basin. But the first thing that stood out was not their number. It was their spacing. No individuals gathered around denser concentrations of marine snow. No cluster feeding formations appeared. Every body maintained an almost equal distance from the others, as if the entire basin were operating according to an invisible biological geometry. The center of the basin, where marine snow rotated gently and accumulated more densely, should have become the most valuable feeding zone in the region, yet nothing entered it. The squid fed only along the outer perimeter, leaving behind a contradiction where food remained present, but life deliberately avoided it. As the expedition widened its observation range, the pattern became harder to ignore. Marine snow no longer fell vertically like it did in stable water. Organic particles slowly spiraled around the basin center, as though being pulled toward an unidentified pressure structure. Deep-sea jelly colonies also held position along the outer perimeter, refusing to drift through the center along their normal trajectories. Particle density concentrated inward. Slow-moving organisms held the outer ring. No predator emerged. No current strong enough existed to explain the behavior. The ecosystem across the entire basin was maintaining a boundary without direct contact. Then a weak pressure pulse moved through the water. There was no silhouette, no collision, no visible hunting event. Yet almost simultaneously, multiple vampire squid released clouds of glowing bioluminescent mucus into the darkness, expanding into wide drifting curtains of luminous debris. This defensive response normally appeared only when a threat became serious enough to justify breaking their carefully conserved energy economy. What made the reaction unsettling was that it happened before the expedition could identify any cause. No tentacle strike, no visible predator, no chase sequence. The entire territory reacted to something that could only be sensed through pressure geometry. The ROV redirected its spotlight toward the basin center. The light itself did not vanish, but particle reflections began to soften. Marine snow in the central region reflected more weakly, as though the density of the water there had subtly changed. The basin center no longer resembled a static void. It looked more like a structure within the water itself, moving extremely slowly beneath the drifting organic layer. When the expedition compared the pattern to earlier phases, a larger logic began to emerge. The barrel eyes had tracked pressure shadows. The tripod fish abandoned their hunting ground. Now the vampire squid avoided the basin center entirely. The ecosystem was not reacting to a visible organism. It was reacting to pressure. The climax came when one vampire squid drifted too close to the center. Its mantle contracted almost instantly. Chromatophores shifted states with abnormal speed. The body jerked downward as if it had crossed into an invisible current. It released a cloud of glowing mucus and retreated upward with far greater force than the surrounding individuals. But it was the mucus itself that produced the most disturbing evidence. Instead of dispersing evenly, The glowing cloud bent sharply into a curved arc, as though an unseen pressure line had sliced directly through the illuminated material. For the first time, the expedition did not see the creature itself. It saw the indirect shape of something moving through the water. Moments later, sonar confirmed that the basin center was no longer stationary. The entire central region was shifting slowly toward the deeper trench below. The vampire squid remained along the outer edge, refusing to follow, as though the entire territory was simply waiting for that region to pass through. Within the silence of the low oxygen water column, the basin no longer resembled a stable environment. It began to resemble the trail of something moving through it. At 3:48 a.m., the expedition descended beyond the familiar abyssal boundary and into the lower abyssal transition, where depths ranged from 3,660 to more than 4,020 meters, before the trench terrain collapsed sharply into the hadal slope below. Sediment here was thicker, softer, compressed into dense layers of organic dust beneath immense pressure. Oxygen levels remained low, but stable. Vertical currents had almost completely disappeared, leaving the entire water column heavy, still, nearly motionless. In an environment like this, even the smallest disturbance appeared clearly on telemetry, like a physical ripple impossible to conceal. After the basin center abandoned its static void state and began drifting deeper into the trench, the expedition was forced to follow, under normal ecological logic, a region that still contained prey signatures, scattered carcass falls, and scavenger activity along the edges should have attracted increasing predator density. Hunting layers should have intensified around any biological pocket this resource-rich. But the deeper the expedition descended, the more completely that expectation collapsed. Sonar still detected small prey clusters moving in scattered formations. Some scavengers continued to appear along the outer boundaries of the anomaly. Marine snow still fell steadily through the water. The energy chain had not vanished entirely. Yet the active predator layer was almost completely absent. The absence became especially clear through the disappearance of fangtooth fish, one of the most effective predators in the deep ocean. With oversized jaws, elongated teeth extending beyond normal body proportions, and the ability to hunt fish and squid under extreme pressure. Fangtooths represented active deep-sea predation at its most efficient. In a region where prey still existed, but hunting turbulence, feeding strike pulses, and predator signatures had vanished entirely. Their absence could no longer be considered random, nor were fangtooths alone. Dragonfish and other pelagic predators had also disappeared. The food web here did not lack life. It lacked predators. The ROV continued scanning closer to the seafloor, searching for activity from opportunistic benthic predators such as cusk eels. Under normal conditions, these organisms patrolled sediment zones in search of carcasses or weakened prey. But the cameras recorded only old movement traces preserved near the edge of the anomaly. No living individual crossed through the central region. The avoidance pattern now extended beyond pelagic hunters. Both midwater and benthic predators were actively withdrawing from the area. As the expedition compiled the data, a colder ecological structure began to emerge. Prey still existed. Scavengers still occupied the perimeter. Carcasses still descended from above. But the active predator layer had been removed almost entirely. This was not a complete ecosystem collapse. It was an extremely selective void within the food chain. The hydrophones confirmed it through a different kind of silence than anything recorded in earlier phases. No tail flicks, no hunting bursts, no body displacement pulses, no feeding strike vibrations. The water column was not merely quiet in sound, it was quiet in predatory behavior itself. If ordinary predators were willingly abandoning a region that still contained resources, then the anomaly below had to represent something larger than any normal survival advantage. Soon after, the sediment began offering another layer of evidence. The ROV detected long parallel grooves aligned closely with the movement direction of the drifting basin anomaly. They did not resemble feeding trenches, current marks, or drag scars left by carcasses. The sediment edges were not violently disturbed. Instead, they appeared compressed by some invisible force before being released. The structures resembled pressure, sheer more than direct biological interaction. They echoed the particle displacement, mucus pressure paths, and elliptical voids observed during earlier phases, but now at a larger scale, clearer, heavier, more physical. As the ROV followed one of the sediment scars, the hydrophone suddenly registered a brief burst. The sound did not resemble a fangtooth strike. It was lower, denser, broader across the pressure spectrum. Almost immediately, marine snow inside the camera frame separated to both sides. Sediment edges trembled faintly. The particle field curved into a narrow distortion line, stretching across the abyssal plane. No silhouette, no outline, no fins, jaws, or visible anatomy. Whatever had just passed through the water revealed itself only by the way the water bent around it. For the first time, the anomaly no longer resembled a vague avoidance zone or an isolated pressure pocket. It behaved like a true movement path, cutting directly across the abyss. Moments later, forward sonar locked onto a massive distortion deeper along the trench slope below. The entire water column bent subtly around a movement that still refused to reveal itself. No biological profile appeared. No visible form emerged. Only the geometry of water reorganizing itself around something descending deeper into the Hadal Trench. This phase did not deliver a creature reveal. It confirmed something colder instead. The most dangerous region of the trench was not where predators gathered in the greatest numbers. It was where even predators disappeared. As the ROV continued descending beyond 4,000 meters along the upper Hadal slope, the expedition was no longer simply tracking organisms. It had begun tracking the way the trench itself, its sediment channels, bottom terrain, and deep microhabitats was gradually reorganizing around a pressure distortion larger than any individual biological response ever recorded. "5:12 on the second morning of the expedition began at the surface with the first layer of daylight touching the waves, but more than 4,000 meters below. The upper Hadal slope of the Tonga Trench remained outside every surface rhythm of day and night, like an ancient ecosystem separated from shallow water time long before human observation ever reached it. As the ROV descended from 4,180 to 4,520 meters, the familiar abyssal plain gradually disappeared. In its place came fractured terrain, descending terraces collapsing into narrow sediment corridors. cracked basalt walls, and thick mud fields broken apart by ancient ridges of exposed stone. Pressure exceeded 440 atmospheres, compressing every living and non-living structure alike. The temperature remained near 1.8 degrees Celsius, cold enough that nearly all movement seemed physically restrained by the water itself. After the forward sonar above the trench slope detected distortions moving through the lower water column, the expedition was forced to abandon its original assumption. This no longer resembled a lone predator drifting into deep territory. Every signal now pointed toward a pressure phenomenon being routed by the trench itself. The ROV continued following the pressure gradient spikes deeper downward, into layers where free-swimming organisms slowly vanished from view. Here, the first signs did not come from fish, not from jellyfish, but from the seafloor itself. Under the spotlight, the hadal terrace appeared not as an empty mud plain, but as a fragile living field stretching across the sediment. Hundreds of xenophyophores covered the bottom in pale branching networks, slow-growing organic structures assembled from seafloor mud, glass spicules, and fragmented mineral debris. These giant single-celled deep-sea organisms built elaborate nests through vast pseudopodial structures, creating stable microhabitats for amphipods, copepods, worms, and benthic crustaceans. Down here, xenophyophores did not simply survive. They shaped the ecological foundation itself. They trapped sediment, captured organic matter, formed entire microscopic forests beneath the crushing weight of the hadal slope. The field remained motionless in near-perfect silence until part of it suddenly folded inward. There was no strong current, no scavenger collision, no sediment slide from above. The delicate structures simply collapsed without warning, as though an invisible force had pressed lightly downward across the entire surface. Surrounding sediment sank into a narrow depression. The microhabitat fractured along a clear path without leaving behind any visible biological form. For the first time, the anomaly was no longer affecting only mobile life. It had reached the slowest foundations of the ecosystem itself. Moments later, benthic scavengers emerged along the edge of the collapsed field. Hadal amphipods organisms evolved to survive extreme pressure through highly specialized biochemical adaptations approached the distorted sediment. But instead of feeding, they stopped. The swarm maintained a clear distance from the newly formed depression. Several individuals circled the perimeter as though sensing a physical aftereffect the cameras could not directly observe. Even for creatures built to endure crushing pressure, the collapsed zone represented a boundary that should not be crossed. Pressure array telemetry began revealing a new pattern. The micro-gradient spikes were not spreading randomly through the trench. They appeared as compact pockets of pressure, lasting only seconds enough to redirect marine snow without forming a true current. Against the immense baseline pressure beyond 4,000 meters, even tiny fluctuations became impossible to ignore. And they were not random. They followed the terraces. They moved through sediment corridors, slid along basalt fractures, passed over carcass funnels, as though the trench topology itself had become a guiding channel system. The expedition began recognizing something deeper. The terrain was no longer background scenery. It was actively shaping the path of the anomaly. Another pressure spike moved directly through the xenophyophore field under full ROV observation. marine snow separated first. The xenophyophore structures collapsed moments later. Amphipods retreated almost simultaneously. Sediment compressed downward. Only 2 seconds afterward did telemetry confirm the measurable pressure increase. Both biological and physical reactions occurred before the sensor array fully registered the spike. When the spotlight lowered toward a deeper terrace, a 40-meter stretch of sediment suddenly compressed flat against the seabed with chilling speed. No body appeared, no tentacles, no plume. Only a region of pressure sliding across the ocean floor like an invisible structure moving through water. For the first time, forward sonar returned a shape, long, distorted, unstable. Not a recognizable organism, no fins, no limbs, no identifiable tissue, yet it was no longer empty space either. It resembled a body composed entirely of pressure gradients. The expedition did not classify it as a creature. Only a new marker was logged. The pressure distortion now possessed directional movement, measurable length, and a clear tendency to follow the trench terrain itself. The ROV descended farther toward the funnel depression ahead, where the pressure gradients intensified with depth. Below, carrion no longer fell directly toward the seabed. Dead organisms had begun rotating slowly in a widening spiral, while scavengers remained frozen along the outer perimeter, refusing to enter the center. (0726). The ROV continued descending through increasingly dense pressure gradients, sliding from 4,680 meters to beyond 5,030 into a narrow funnel depression suspended between the steep walls of the hadal slope. The current here was not chaotic. It rotated slowly along a vertical axis, thickening the suspended sediment within the water column until visibility faded into a dense mineral haze hanging through the darkness. Pressure pulse frequency had increased significantly compared to the previous layer. After sonar earlier detected a stretched and unstable pressure distortion, the expedition stopped searching for a direct biological form altogether. Instead, the entire observation system was recalibrated to follow the pressure spikes deeper into the trench. Hydrophones positioned near the funnel began recording increasing scavenger activity. The ROV stabilized near the outer rim, monitoring drift direction, organism behavior, and every environmental change surrounding the center of the depression. The first thing illuminated by the spotlight was not a living organism. It was a field of slowly rotating carcasses suspended in the water column. Lanternfish, small squid, clusters of amphipods, fragments of gelatinous tissue. None of them descended normally through the abyss, but neither were they being thrown violently by natural currents. Every carcass rotated along the same stable vector, suspended within the water column, as though trapped inside an invisible vortex. Some drifted closer toward the center before gradually spiraling back outward. Even the surrounding marine snow bent into synchronized microscopic curves. The current meter registered only weak movement, nowhere near enough to explain such an organized rotational structure. Different body masses, different tissue densities, from squid mantles to gelatinous debris. Every object behaved as though submerged inside the same invisible physical field. But the strangest part was not the dead organisms. It was the refusal. Along the outer edge of the spiral, dozens of giant isopods formed a distinct scavenger ring. These deep-sea crustaceans famous for exploiting any rare source of protein, stopped completely at the perimeter. Not one crossed into the center. Several lifted the front of their bodies toward the water ahead, as if testing an unseen gradient, before immediately backing away. No feeding, no competition, no scavenger behavior expected from an ultra-low energy ecosystem. The squid and fish carcasses continued rotating directly in front of them. Yet the biological ring held firm like a forbidden boundary. In the deep sea, ignoring accessible food represented a stronger ecological contradiction than predation itself. A large grenadier approached the spiral from lower water shortly afterward. This mobile predator scavenger species normally exploited every protein opportunity across the abyssal plain. But the moment its head neared the curved particle boundary surrounding the center, its movement changed direction almost instantly. No attack, no feeding attempt, no sign of another predator nearby. It simply turned away, as though it had encountered a contour boundary that could be sensed but not seen. Not only benthic scavengers, but even active predator scavengers were refusing to enter the suspended carrion field. To determine whether the phenomenon was merely an unusual current anomaly, the expedition deployed a pressure-reactive filament array directly into the spiral center. As the ribbons approached the core region, the entire filament structure compressed violently downward before snapping upward again despite the current meter, showing no matching acceleration. Nothing touched it. No major sediment plume formed. No evidence of direct mechanical collision appeared. The event was logged as localized pressure field behavior, suggesting the surrounding water column was undergoing abnormal compression and expansion forces. Immediately after the filament array was withdrawn, the marine snow near the funnel center began disappearing more rapidly. It did not sink. It did not disperse. It looked as though the particles were being compressed into the water itself. The scavenger ring retreated farther outward, widening the perimeter. One squid carcass slowly rotated toward the spiral core. No bite marks appeared, no tearing. Its mantle suddenly collapsed inward as though compressed from within. A tiny cloud of blood erupted outward before immediately folding into the rotating spiral, dissolving into the synchronized current. The giant isopods retreated again. The grenadier did not return. Even the small amphipods along the sediment rim stopped moving entirely. Moments later, the hydrophones recorded the strongest pressure pulse since the expedition first entered the trench anomaly. Immediately afterward, the entire spiral reversed direction for nearly 4 seconds. The carcasses did not scatter chaotically. Every rotating body changed vector simultaneously, as though the entire system had received a new navigational command. The observation confirmed something far more disturbing. The pressure field was not behaving like a passive distortion. It possessed the ability to direct the movement of matter within the water column itself. As the ROV withdrew from the funnel depression, the spiral behind it gradually slowed. But by now, the central question had completely changed. This was no longer a phenomenon involving carcasses rotating through deep water. The more unsettling reality was the ecological logic surrounding it. Carrion was present. Scavengers were present. Predator scavengers were present. Yet the entire survival system of the deep sea was collectively refusing to enter the center of an exposed food source suspended directly in front of them. Higher above, along the elevated terraces where hadal vertebrates still maintained their presence, the expedition prepared to encounter another contour boundary, a place where the snailfish did not disappear. They stood instead like a living forest along the edge of water that even scavengers refused to cross. At 10:03, the expedition drifted along the upper Hadal forest terraces between depths of roughly 5,400 and more than 6,100 meters, where the seafloor no longer carried the spiral structure of the dead zone above. Instead, the trench opened into a softer terrace system, layered with tall sponge stalks, scattered xenophyophore towers, shallow sediment ledges, and long mud slopes descending gradually into the deeper basin below. Oxygen levels remained low, but stable. The current moved weakly and continuously, almost too faint to create any obvious disturbance. But the marine snow above no longer fell in the familiar vertical descent. Thin ribbons of organic matter had begun drifting sideways across the water column, slowly and consistently, as though some invisible force beneath the trench floor was subtly altering the trajectory of everything sinking through the deep. Beyond the dead spiral, vertebrate density in this region was far higher than projected by any previous model. Life still existed here, but it was no longer distributed freely. The ROV left the carcass route and followed the terrace slope instead, where biological signals no longer clustered around feeding grounds, but appeared concentrated along the edge of something unseen. Under the survey lights, dozens of hadal snailfish slowly emerged against the sediment layer. Their bodies looked almost unfinished in the darkness, soft gelatinous tissue, reduced skeletal mineralization, and biological structures that had nearly eliminated all dependence on gas-filled cavities. Everything about them was built for crushing pressure. They were not misplaced deep-sea vertebrates surviving at the edge of tolerance. They were evidence that evolution had already produced a complete vertebrate form designed specifically for the hadal abyss. Each individual hovered low above the mud, like pale drifting leaves suspended in cold black water. No feeding behavior, no courtship, no territorial motion. The clusters stretched loosely across the terraces like a silent living forest. What stood out immediately was their orientation. Every snailfish faced the same direction, toward the deeper side of the trench. Fin movement remained minimal, barely enough to maintain position against the weak current. This was not panic behavior. It resembled something far older and more stable, a prolonged state of waiting, as though the entire snailfish forest existed along the upper boundary of something none of them were willing to cross. Expanded mapping confirmed the pattern almost immediately. Not a single individual descended beyond a specific depth contour. Below that boundary, food particles still drifted through the water. Marine snow remained active. Detritus had not disappeared. This was not a starvation zone, and it was not dead water. Life had not vanished beneath the contour. It had simply organized itself above an invisible line with astonishing ecological precision. When the ROV scanned a nearby sediment plain, the same pattern appeared again among a group of abyssal sea cucumbers. The slow-moving detritivores continued feeding normally through the organic mud until they approached the contour boundary. Then the entire group changed direction at once. No predator appeared. No current strong enough to force movement crossed the trench. They simply turned away, as if the seafloor itself were emitting a signal recognized by both vertebrates and bottom feeders alike. The hadal ecosystem was beginning to reveal itself as a fixed survival geometry. The snailfish held the upper edge. The sea cucumbers withdrew from the contour. Amphipods maintained an outer feeding band. Marine snow beneath the boundary continued drifting sideways. This was no longer a temporary avoidance response. It was a long-established ecological structure. Then a small pressure pulse swept across the trench. The Snailfish Forest froze instantly in the water column. Fin movement nearly stopped altogether. Several seconds later, the entire cluster drifted upward together by a few meters. No chaos, no scattering, just a familiar positional correction performed with precise coordination, as though the response had already been repeated across countless cycles before the expedition ever arrived. As the ROV approached the contour boundary, pressure telemetry spiked sharply. One nearby snailfish suddenly stiffened. Its tissue trembled faintly beneath the soft, translucent skin before it retreated rapidly upslope. None of them remained below the line. The camera lowered deeper into the trench. Below the boundary, marine snow no longer fell downward. It slid sideways across the hadal floor in long streaming bands, as though an enormous pressure flow were silently sweeping just above the basin floor. The contour was no longer just a depth marker. It was the upper edge of something far deeper in motion beneath the trench. And for the first time, the expedition decided to descend beyond the boundary nearly every hadal vertebrate had refused to cross. At 12:48 p.m., the ROV crossed the contour boundary between depths of roughly 6,420 and nearly 6,880 meters, descending into the lower hadal trench, where the walls narrowed sharply, steeper, darker and heavier, beneath the near absolute pressure of the abyss. This was no longer a region where organisms reacted temporarily to an anomaly. The biological distribution in the upper layers had already revealed a clearly organized threshold, a depth where most hadal vertebrates stopped and refused to descend any farther. Once the expedition crossed that limit, the mission shifted beyond simple observation of avoidance behavior. The sensor array began triangulating the pressure event itself, attempting to determine the direction, velocity, and movement structure of whatever was reorganizing the trench ecosystem on such a massive scale. Pressure fluctuations appeared more frequently now. Hydrophone saturation continued rising. Scavenger density dropped to unusually low levels, as though even the smallest survival opportunities were no longer enough to pull most organisms into this part of the trench. Along a narrow sediment ridge where food particles still settled, a group of amphipods and juvenile snailfish continued feeding near the lower edge of the boundary. They never crossed into the deeper zone. They only exploited the last remaining resources along the border. Then a pressure pulse passed through. No sudden sound, no violent current, no visible predator entering the frame. In less than 2 seconds, 3 amphipods died where they stood. One juvenile snailfish collapsed almost instantly, its tissue structure failing as the body lost internal stability before drifting away from the sediment line. The remaining organisms moved upslope together. No chase response, no tearing, no contact. These were creatures already adapted to immense hadal pressure at both anatomical and molecular levels. They were not killed by depth itself. What caused the fatalities was something far stranger, a localized distortion within the very pressure environment they had evolved to survive. The ROV approached the carcasses before they fully sank into the sediment. Optical zoom and LiDAR scans revealed no bite marks, no puncture wounds, no toxin discharge, no tearing, and no signs of direct mechanical impact. The internal tissue appeared compressed inward from within the body itself. Several soft regions along the juvenile snailfish had deformed in the exact vector direction of the passing pulse. The expedition classified the event only as pressure trauma, a form of damage unlike predation, scavenging, or normal decomposition, not a confirmed biological mechanism, but a new ecological pattern where pressure itself had become a direct cause of death. As the carcasses still drifted near the trench floor, a cusk eel appeared at the edge of the frame. As an opportunistic scavenger predator, it approached the body slowly, following the ordinary logic of deep-sea feeding behavior. But the moment it neared the death zone, it stopped. No visible threat existed, no chase, no competition. And yet it retreated almost immediately without feeding. Carrion remained present, the scavenger remained present, but the pressure field overrode feeding behavior entirely. Once again, the ecosystem prioritized avoidance above energy survival itself. Data from the pressure array, hydrophone timing, marine snow displacement, and ROV inertial readings finally produced the expedition's first major breakthrough. The pressure event did not propagate like an ordinary wave. It did not resemble microtremors, current fronts, or conventional mechanical strikes. This was an extremely narrow localized pressure burst moving along a defined vector, sweeping laterally through the ecosystem like a directed corridor of force. Scavengers arrived before death. Predators refused carcasses. Jellyfish avoided the corridor. Snailfish avoided the contour. Carcasses imploded without being bitten. For the first time, every ecological pattern converged toward the same conclusion, a moving pressure field with a distinct path through the trench. Then the burst appeared directly in front of the camera. Marine snow, previously suspended almost motionless within the immense ambient pressure, suddenly compressed into a thin, dense layer before violently splitting apart to both sides, as though some invisible structure had torn open the water itself. The ROV frame shook harder than at any earlier stage of the expedition. The hydrophone recorded a deep, low-frequency pulse beneath every previous acoustic anomaly detected in the trench. Yet telemetry showed no matching increase in physical current. There was no true water flow, only pressure moving through the abyss. For the first time, the pressure field no longer existed, merely as an inference drawn from animal behavior. The marine snow itself had become a visible screen tracing its path. Several minutes later, a juvenile snailfish drifted too close to the burst vector. For a brief instant, its body bent inward along an unnatural angle. Ocular tissue hemorrhaged lightly. The soft internal structure collapsed before the animal died silently in the water column. No organism appeared, no anatomy, no visible predator entering frame, only the invisible trajectory of pressure itself. Then the forward sonar detected something. Far out in the abyss, an enormous outline appeared briefly at extreme range. No clear body, no identifiable shape. Only the surrounding water compressing, warping, and shifting around it on a scale larger than any whale-sized organism ever documented within the trench. This was not a full reveal, but for the first time, the pressure field now had direction, scale, movement, presence. The expedition did not continue direct pursuit. Attention shifted instead toward a far deeper question. If most organisms in the trench could not see whatever was moving through the abyss, which species had learned to sense it before the pressure wave arrived? (1507). After nearly 34 continuous hours operating beneath the Tonga Trench, the expedition had descended deep into a lower hadal migration corridor between 7,020 and 7,310 meters, where narrow sediment ridges threaded between compressed pressure basins like ancient survival pathways buried beneath near-terminal pressure. Particle density here had dropped significantly. Oxygen levels were lower, though still stable enough to support slow biological chains. The hydrophone registered only faint background pressure pulses, almost beneath meaningful detection thresholds. After the sonar first captured the massive pressure silhouette deeper below, the expedition's objective was no longer direct observation of whatever was moving through the trench. The focus had shifted. If the entire ecosystem reacted before the pressure pulse itself became detectable, then the more important question was which organisms sensed it first, how they sensed it, and why the trench appeared to coordinate itself like a unified sensory network. The ROV redirected toward a group of hadal rat-tail fish patrolling along the sediment edge. These opportunistic scavenger predators were already adapted to cruising near bottom fractures, constantly responding to weak vibrations, water displacement, and subtle mechanical changes around the substrate. In near total darkness, the lateral line had become one of their primary survival systems, allowing them to read microscopic pressure gradients long before eyes or sonar could confirm any visible structure. At first, the entire school fed normally around the sediment cracks. No silhouette, no burst vector, no visual indication that the anomaly was present. Then the entire school froze. No panic burst, no sudden directional shift, no scattering response. Movement simply stopped almost completely. Fin stabilization tightened. Every body aligned toward the same vector, as though the entire group had sensed an invisible disturbance entering the corridor. When timestamps from the video feed, sonar, hydrophone, and pressure telemetry were cross-referenced, the expedition uncovered a critical discrepancy. The rat-tail fish reacted roughly 11 seconds before the pressure pulse became clearly detectable by instrumentation. The equipment confirmed the pulse only afterward. This was not a reaction to a direct attack, not an escape response from a nearby predator. They were responding to a precursor signal, an extremely weak displacement event arriving ahead of the main pressure disturbance itself. The expedition stopped short of calling it future prediction. But based on known mechanosensory biology, the lateral line became the most plausible explanation for detecting physical changes that human instruments still lacked the sensitivity to fully resolve. Deeper into the corridor, a cluster of juvenile hadal snailfish foraging unevenly near a sediment ridge reinforced the pattern again. Moments before the next pulse arrived, The entire group drifted upward in unison. No sprinting, no chaotic dispersal, no individuals breaking timing. They simply lifted higher into the water column as though a dangerous vector was beginning to form near the seafloor. This marked an important transition in the data. Anticipatory behavior was no longer isolated to a single pressure-sensitive scavenger species. A multi-species vertebrate response was becoming visible now, suggesting the trench was operating through a far broader sensory hierarchy. One rat tail near the ridge then displayed abnormal behavior. A slight twitch along the flank. Fin stabilization lost rhythm for several seconds. Body alignment slipped away from the shared vector before gradually correcting itself. Marine biologists aboard the expedition logged the event as a possible form of sensory overload, where the pressure precursor may have exceeded the normal processing threshold of the mechanosensory system itself. If the lateral line truly functioned as a distributed warning network for water motion, then this pressure field might already be operating as an amplified signal, powerful enough to disrupt behavior without requiring any direct physical contact at all. As the data was layered together, the trench-wide pattern became clearer than ever before. Scavenger retreat, jellyfish shutdown, amphipod freeze, rat-tail alignment, snailfish drift, marine snow tilting first, pressure telemetry arriving second. These were no longer isolated reactions. The entire hadal corridor was behaving like an ecological sensory network, where the most pressure-sensitive organisms responded first, slower species adjusted afterward, and the migration corridor itself opened before the pressure pulse physically arrived. The organisms were not avoiding a visible body. They were avoiding the pressure change moving ahead of it. The escalation came when the hydrophone finally recorded the largest pulse yet observed. But the ecosystem had already frozen nearly 14 seconds earlier. One rat-tail fish positioned too close to the sediment ridge lost orientation completely, spiraling through the water for several seconds before dying without visible trauma, no external damage, no bite marks, no predator contact, no silhouette appearing anywhere in the camera feed. Immediately after the pulse, the marine snow beneath the trench separated into a long, sharply defined corridor stretching across the lower basin. It did not resemble a current path. It did not resemble natural turbulence. It looked as though the entire ecosystem had parted to either side, making way for a larger pressure geometry moving through the trench. And if the corridor could open before the pulse itself even arrived, then whatever the trench was sensing might not be the pressure field at all, but a signal traveling ahead of it. (1832), the ROV continued descending into the largest pressure basin the expedition had entered so far, reaching depths between 7,480 and 7,890 meters beneath the surface. The trench walls narrowed further here, forming an almost enclosed geological corridor where ultra-fine sediment rested softly across the seafloor, like layers of organic dust untouched by major disturbance for centuries. Vertical current had nearly vanished completely. The water column felt heavy, slow, and so quiet that even minor particle movement stood out like a physical irregularity. After the marine snow corridor from the previous layer opened like an invisible pathway deeper into the trench, the expedition chose to follow it directly into a region where sonar stability began deteriorating continuously. The objective was no longer simply tracking the organisms avoiding the anomaly. It was determining whether the corridor itself was the product of biological behavior or merely the outer boundary of a moving pressure field. Forward sonar began distorting almost immediately after the ROV crossed into the basin. The distortion was not fixed like seafloor terrain. It did not remain stationary. Misaligned reflection zones drifted slowly in the same direction as the corridor itself, as though the structure of the water column ahead was changing shape. No bubble field appeared. No major thermal gradient was recorded. No nearby cliff wall existed large enough to create conventional reflection error. The sonar was still functioning. It still returned signals from the water column. But those signals no longer matched the physical positions observed by the camera. That made the anomaly far more unsettling than a simple signal loss. The instruments were not blind. They were beginning to see the water in the wrong place. Inside the ROV's light beam, marine snow remained clearly visible. Organic particles continued falling, drifting, rotating slowly, just as they had throughout the deeper layers. But the sonar no longer mapped them correctly. Some particles appeared clearly on camera, then vanished entirely from acoustic mapping for several seconds. Other reflections appeared offset from their actual locations, as though a layer of medium existed between camera and sonar with abnormal density behavior. Conductivity remained nearly stable. Temperature barely changed. Salinity fluctuations were nowhere near strong enough to explain the phenomenon. Only the pressure-density relationship oscillated in repeating narrow bands throughout the basin. Hollow water was not empty water. It was water where different methods of measurement no longer agreed on physical reality. As the expedition maintained course, several jelly drift colonies began appearing along the edges of the corridor. These soft, gelatinous organisms, almost entirely dependent on fluid movement, were among the most sensitive biological indicators of water column behavior. They drifted slowly toward the distortion zone, then all changed direction simultaneously. None crossed deeper inside. No measurable current shift. No visible predator. No physical barrier. The entire colony reacted as though it had reached a boundary, detectable only to organisms living fully within the water itself. If the camera and sonar were still in disagreement, the gelatinous ecosystem had already reached a far more decisive conclusion. This water should not be entered. Composite mapping across multiple layers showed that nearly every hadal organism crossing that contour line displayed one of three identical responses: retreat, reroute, or freeze. There was no cliff edge, no visible oxygen wall, no fixed terrain structure explaining the boundary. This was a biological border created by pressure geometry rather than seafloor geology. The expedition was beginning to understand that the trench was not simply avoiding a particular organism. The entire ecosystem was avoiding regions where the structure of the fluid itself had been reorganized. The sonar void then expanded around the ROV. Marine snow, previously falling in relatively straight paths, began bending into displaced arcs. The ROV itself remained nearly stationary, yet the surrounding particle field curved sideways as though the water were rerouting physical movement around something unseen. No current meter registered a matching shift. To verify the anomaly, the expedition released a cloud of microbead tracers directly into the hollow water. The camera tracked the beads clearly. The sonar lost them within seconds. Then the entire trajectory of the beads began curving outward to both sides, not from turbulence, not from collision, not from predator interaction. The fluid density itself, or the pressure architecture surrounding it, was being bent. For the first time, the expedition was not merely observing organisms avoid the anomaly. It was witnessing inorganic matter itself being displaced away from its natural descent path. Hollow water was no longer a hypothesis. It was a physically distorted region of the ocean. Finally, the hydrophone recorded multiple pulses overlapping into a distinct rhythm, no longer isolated pressure events. They were denser now, closer together, more regular, like a system accelerating somewhere deep inside the trench. The expedition was no longer entering an empty region. It was standing inside the movement trail of an active pressure field. The ROV remained stationary within the hollow water zone, waiting for the field itself to pass directly across its position. As the entire expedition slowly realized that whatever they had been tracking may never have needed to reveal itself through ordinary biological form. It might have been hunting through the way it bent the water around itself. 10:11 p.m. At depths fluctuating between roughly 8,010 and 8,360 meters, the ROV held position inside the hollow water zone under a decision unlike any made during the entire expedition. Instead of continuing to track the moving anomaly, the observation system shifted into a fully stationary state, allowing the pressure field itself to pass across the vehicle. Visibility had nearly collapsed inside the dense hadal water column. Pressure fluctuations pulsed in uneven compressions that resisted prediction. The current meter showed no significant flow, yet marine snow continued bending gently around the camera frame, as if the water itself were being shaped by a structure that still remained unseen. Almost no active predator fauna appeared anywhere inside the observation zone now. The objective was no longer to pursue a creature, but to determine whether this pressure geometry truly represented a stable mechanism. For a few brief seconds, the forward LiDAR and sonar finally captured the breakthrough the expedition had been following through multiple phases. An elongated outline emerged, not as a flesh silhouette, carrying neither fins, tentacles, nor any recognizable morphology associated with whales, squid, or large predatory fish. Instead, the sensors only detected a stretched distortion body extending for dozens of meters, its boundaries unstable, with the surrounding water visibly compressed and warped around it. The sonar contour did not return a clear body. It returned a deviation in the acoustic behavior of the water column itself. What had been observed was not enough to confirm a new species. The expedition could only document a living structure, or a directed locomotion mechanism, massive in scale and surrounded by a pressure field strong enough to cause the contour of the water itself to be misread. Directly ahead of the distortion body, a dense swarm of hadal amphipods suddenly separated into two sides. They did not panic. They did not scatter chaotically or burst upward in flight. The entire swarm simply opened into two curved biological edges, forming a clear avoidance corridor before the pressure field even arrived. This was not a panic response. It was organized avoidance. These creatures, already evolved beneath extreme pressure, were not avoiding shape. They were avoiding the pressure geometry that moved ahead of shape. That alone suggested the trench ecosystem was no longer reacting randomly. It had learned to read the path of the apex mechanism long before the expedition ever understood it. From this point forward, the scattered patterns from earlier phases began locking together into a larger hypothesis. The marine physicist on board proposed that this hunting mechanism might not rely on teeth, pursuit, or visible strikes like conventional predators. Instead, the organism, or structure, appeared capable of generating localized pressure collapses or compression zones within the water itself. As the pressure field swept across prey, orientation could fail, sensory systems could overload, soft tissue could compress unevenly, internal gas structures could collapse, and circulatory damage could occur before any physical contact ever happened. It explained why earlier carcasses carried no clear bite marks, why jellyfish shutdown events occurred before contact, why snailfish avoided specific contours, why scavengers often arrived before death events, and why conventional predators vanished completely from the path zone. The trench no longer resembled a chaotic ecosystem. It now appeared as an environment organized around a stable apex mechanism. Jellyfish reduced their bioluminescence signatures to avoid exposure. Rat-tailed fish suffered sensory overload from hydrodynamic gradients. Snailfish remained precisely along safe contour boundaries. Scavengers timed their approach in cycles. Predators avoided the entire region. Amphipods opened corridors. None of it was random anymore. This ecosystem was not dominated through speed or direct violence. It had adapted around a law of pressure. As the distortion body moved closer to the ROV, the tension no longer came from shape, but from environmental physics. Marine snow compressed into arcs around the outline. The camera frame vibrated even while the current meter still showed no strong flow. The hydrophone overloaded beneath low-frequency pulses. The outer shell of the ROV released the loudest metallic strain, sounds recorded since the expedition began, as though the entire structure were reacting to enormous pressure energy moving through the water. Then, in less than 3 seconds, the distortion body passed across the flank camera. The water around it folded into overlapping curved layers. Marine snow vanished completely from the center zone. Sonar lost direct returns. The camera did not see a body in the ordinary biological sense. Instead, what existed there was a shell of water itself, bent, compressed, and organized around a form that could not be directly observed. The expedition finally understood that the organism was not invisible. It was hidden by the pressure field it generated. It did not hide inside hadal darkness. It hid inside the mechanics of water. Just before the distortion body disappeared beyond sonar range, a brief moment appeared within the pressure shell. A structure carrying biological symmetry surfaced for an instant, as though part of an anatomy were expanding or reorganizing inside the compression zone. The image was too brief to define anatomy, too unstable to classify, but enough to confirm that inside the pressure distortion was not merely a physical phenomenon. There was a living structure. The expedition did not call it a monster, whale, or squid. No species label was assigned. Only a single observation was entered into the record. Apex mechanism observed. Biological symmetry present. Pressure field obscures morphology. After the distortion body vanished deeper into the trench, the ROV remained motionless within the heavy, nearly static water column. The question was no longer what it was. The next question was how the entire trench would recover after this pressure hunting mechanism had just passed through. "2:36 a.m. At depths exceeding 8,200 meters, the expedition stabilized the ROV at the deepest fixed observation point of the entire mission, after the massive pressure distortion had crossed the flank camera and disappeared deeper into hadal darkness. No further pursuit attempts were made. The objective had fully shifted away from tracking the unseen predator. Something more important now demanded observation how the trench itself would recover after the pressure field moved on. Inside the near total darkness, the hydrophone began collecting the first returning layers of biological acoustics, faint enough to almost dissolve into the compressed water background, yet sufficient to confirm that a transition had begun. During the first 14 minutes after the final pulse, the trench did not suddenly come back to life. It rebuilt itself layer by layer. Marine snow, once bent into pressure arcs around the ROV, gradually resumed its familiar vertical descent. Sediment stabilized across the seafloor. Sonar distortions slowly weakened. Pressure telemetry lost its abnormal spikes. The particle field no longer carried the hollow sensation of water being warped by an invisible force moving through it. Sonar and camera systems, once drifting out of sync inside the distortion zone, gradually realigned, as though the physical space surrounding the expedition were returning to measurable normality. There was no sense of victory, no escape moment, only the deep ocean reorganizing itself after a pressure mechanism had withdrawn from its survival corridor. Higher in the water column, the scattering layer began shifting once again along familiar migratory rhythms. The hydrophone recorded the first faint biological turbulence, followed by distant biological clicks, then the slow return of thin shrimp static spreading back into the soundscape like a background frequency that had once been erased entirely. In deep-sea ecosystems, these tiny snapping sounds often serve as the baseline signal of normal biological activity, proof that predators, prey, and environmental interaction chains are functioning again. The sounds recalled the baseline acoustics from the earliest expedition phases, when the ocean still carried a stable background rhythm before the abnormal silence spread through the system. Now their return no longer represented sound alone. It signaled that the trench had allowed biological movement to emerge again. Along contour edges that had once been abandoned, hadal snailfish began returning. They did not descend into the corridor previously occupied by the predator. Instead, they reclaimed only the livable sediment margins where the pressure boundary had shifted away. Their fin movement remained slow and steady, no longer freezing mid-water. Some individuals resumed sediment feeding, rebuilding familiar survival rhythms. More than any direct encounter, this confirmed a deeper logic. The trench had never been a permanent dead zone. It was a dynamic avoidance map, where survival boundaries shifted according to the presence of the pressure hunter. After multiple phases of absence, fangtooth signatures also reappeared on sonar. Not as apex threats, not as anomalies. They returned as ordinary deep-sea predators, with small hunting turbulence emerging near the edge of the observation zone. Several prey signatures separated from the sediment edge in familiar defensive responses. Predatory ecology was functioning again. This suggested conventional predators had never vanished entirely. They had only abandoned their hunting rhythms temporarily, while the larger apex pressure mechanism remained present. As the expedition began compiling the full dataset, a complete pattern gradually emerged: acoustic silence, migration reroutes, light shutdown, scavenger delay, contour avoidance, predator disappearance, marine snow compression, hollow water. None of these had ever been isolated phenomena. They were unified survival responses spread across the entire trench. Silence had never meant the absence of life. Silence was a survival state. This entire hadal ecosystem had evolved, or at minimum organized its behavior, around an environmental force powerful enough to make every biological layer reduce movement, suppress bioluminescence, abandon corridors, cease hunting, delay scavenging, and only return once the pressure field dissipated. The true meaning of the silent trench was never a lifeless abyss or an empty void. The more disturbing reality was that the life down there knew exactly when to become silent. The pressure hunter did not require pursuit. It did not require visible attacks or speed. If this mechanism truly existed, it hunted by restructuring the physical environment around itself, forcing the entire trench to reorganize according to its pulses. Migration timing, feeding duration, scavenger return, predator withdrawal. Boundary shifts, the entire ecological logic of the trench appeared to revolve around a pressure phenomenon that had never been fully understood. During the final hours at the deepest observation point, the hydrophone continued recording thin shrimp static drifting through the abyss like background breathing. Far above, whale clicks echoed downward through multiple water layers like ancient signals from the surface world. Marine snow fell steadily for the first time in hours, no longer dragged sideways or bent into compression arcs. Snailfish drifted slowly along sediment edges. Amphipod swarms resumed feeding. Jellyfish pulsed in scattered clusters of dim light. Fangtooth once again became nothing more than ordinary predators inside the darkness. The ocean had never been empty there. Every organism inside the trench had simply learned to become silent before the pressure began moving through the water.